Hi everybody. So in this lesson we're going to be looking at Earth's resources, specifically focusing on water, how we treat it and how it can get cleaned enough to be put back into the environment or to be reused by us. So first we have to look at what is a finite and what is a renewable resource. So finite resources are resources that are going to be used up at a faster rate and they cannot be replaced. Once they are used, they are gone. Something like fossil fuels are a finite resource. If we use all the Earth's fossil fuels, there is no way of getting that back. It will take, I don't even know, like millions of years, thousands of years, maybe millions of years more like it, for those resources to be replenished. Okay, so in that time, it is not considered a renewable resource and we consider them finite resources. So something like our metal ores that we extract from the earth are finite resources. Eventually there won't be any iron on the surface of the earth that we can mine. There'll be iron, I guess, underground, but eventually that would have to come up with movement of tectonic plates. Again, thousands of years to do. So metal ores are also finite. When we look at renewable resources, these are resources that can be replaced at the same rate that they are being used. Something like ethene, which is made of ethanol, which is derived from sugar and beet, is a renewable resource. So through manufacturing processes, ethene is going to be made, which can then be used at the same rate that it is being made in those manufacturing processes. Another one would be wood chips. So instead of fossil fuels, we can look into fuel power stations using wood chips or other scraps, because those scraps will continue to be made. So we might as well use them as they are being made. Thus, it becomes a renewable resource. Trees will always grow. If we use them in a correct and sustainable manner, they will last us forever, you see. Now let's look at water. So what is safe drinking water? We refer to it as potable water. Potable water is fit for human consumption. Now, a lot of people think that you can just collect rainwater and drink it. But the issue is, when we have all these emissions in the air from factories, from our cars, pollution, okay, it's going to collect in the clouds because it is also a gas, just like the clouds are gaseous water. Those are going to mix together, and when it rains, the rain will contain those contaminants as well. When it gets really bad, it can form acid rain, which can be very harmful to our health, the health of plants. It can damage clothes and structures. Okay, but rainwater that we drink today, or that we have today, is not going to be very drinkable. It's not going to be potable. So how do we achieve potable water from these natural sources? Same thing with rivers. Rivers are going to, no matter how clean they will always contain these dissolved solids. And it's good for us, okay? We can't drink distilled water because distilled water is just H2O. It'll actually dehydrate you because you need those minerals in the water to be able to absorb them effectively into your body. So minerals are always going to be dissolved as well as decaying matter in some microorganisms. But what we have to do is make it fit for human consumption. How we do that is first by filtering out large debris. We're then going to do a settlement tank. That means that all the heavy objects that might have gotten through the initial filter will settle to the bottom, while the runoff at the top will then move on to the next stage, which is aluminium sulfate plus lime. And what that's going to do is all the particles, the microscopic particles, are then going to clump together and they will also become heavier and fall to the bottom of that tank. Then we're going to go through sand filtration. So sand filtration would have taken out the big particles, but what's going to happen is we're going to have to then clean that because it will clog it up. So we go through those previous stages before the sand filter, which will take out the microscopic bits and pieces. We're then going to treat it with UV light to kill any microbes. What we can also do is add chlorine in a certain amount, and that's going to kill all microorganisms in it. And then we're going to do a pH correction. so that it is okay for us to drink. And then this is what our bottled water will be made out of, is this treated water. But interestingly enough, the amount of dissolved solids in your bottled water can be read as it should say there, total dissolved solids. Now, what those dissolved solids are, or where they came from, is sometimes very questionable. But they have deemed it okay to drink these dissolved solids. But it's still interesting to know what they are exactly, and you should do some research to see exactly what they are. So the water that we use is afterwards considered wastewater. This means that it is not suitable for human consumption again, but it is also not suitable to be put back into the environment. This could be because it has chemicals in it, it has large waste products, I'm sure you can imagine what those are, and it must then be treated before being put back into nature, so that it does not harm nature. So how exactly is this treated? We use something called primary treatment, which is the solid sediments that settle out. We're then going to use biological treatment. So what this is going to do is use bacteria to feed off of the organic matter and convert it into matter that won't be as destructive to the environment. Okay, this is a aerobic reaction, so it has to be in the presence of oxygen with these bacteria. And then we're going to have sludge digestion. Now, when we're talking about sludge and wastewater, a lot of the time it's going to be sewage water. So you can only filter out so much sewage before it has to be broken down by the bacteria in the presence of oxygen. And what can happen is during this breakdown process, gases can be released, such as methane and other biogases. And this methane can then be used to generate electricity or to heat up houses. It's very effective, and biogases should have more research into them because there will always be waste treatment facilities. We just have to figure out how to harness the biogases that are going to be released from them. So first it is going to be screened for any large objects through a metal grid. Then we're going to have the primary treatment. Okay, this is where sediment is allowed to be settled to the bottom. That sediment can then be removed and taken out as sludge, as we see here. Secondary treatments is when we're going to be using the bacteria that are going to feed on the remaining organic matter, and other harmful microbes will be killed. And finally, we're going to have the treatment where the useful bacteria are allowed to settle to the bottom. And what's going to happen is we're going to treat it for UV and chlorine as well before putting it back. But that sludge that we initially took out can then be used for fertilizer or for this biogas manufacturing. So we said earlier that these metal ores are a finite resource. How exactly do we extract the useful metal from the ore? Well, the first way is by sulfuric acid. So we can dissolve the ore in acid, and this will then form something like copper sulfate, which can then be extracted and then refined. Another way is by smelting, and this is usually the more popular method. We are going to completely melt the ore being a mixture between metal and rock. If you ever play Minecraft, you'll know this. You smelt the ore to get ingots. This is exactly the same thing. What's going to happen is that ore is going to separate from what we call slag. Slag is like the molten rock that's going to come to the top, and the valuable metal is going to settle to the bottom. We remove that slag, and then we're going to be left with the metal. More biological or biotechnology methods of extracting ores or of extracting metals is going to be through phytomining. This is when they use specific plants that have adapted to pulling the metal atoms out of the soil. This can be used a lot of the time for areas that are contaminated, let's say with heavy metals, as well as radioactive areas where you're trying to get the soil to be less radioactive. You plant your crop, the crop is going to pull out all of that radioactive metal or the valuable metal, and then what you will do is you're going to burn the plants, thus leaving yourself with ash and metal. You can then separate those two and refine the metal. Another one is bioleaching, which pretty much does the same thing, but by using bacteria to feed on this low-grade metal ores instead. And then we are able to separate the metal from the bacteria. So next we're going to be looking at the life cycle assessment of certain materials. So basically it's the principle of mapping the journey from cradle to grave for the manufactured products. So it's used to assess the impact on the environment that is caused by, so how is the product going to be obtained? Okay, is it from the environment? Is it damaging the environment just to get it? The making of the product, so how is it manufactured? What is the effect on the environment through the manufacturing of it? The using and reusing and maintaining of the product. So some of these products won't just be extracted from the environment, processed, and then be okay. Sometimes they have to be maintained, which is going to take more resources and harm the environment even more to maintain. And finally, the disposing of the product. So some of these products are going to harm the environment by disposing of them. Just think of plastic. So plastic doesn't have much of an effect on the environment through extraction of the environment, but the manufacturing process is going to create a lot of emissions. Then the using and reusing of the product, we know, is going to make a lot of waste, okay, as well as microplastics, which are damaging not only us but all living things around us. And then finally, as we know, the disposing of these plastic products is going to be in a waste dump that they're going to sit in for the next couple hundred years before they dissolve into smaller plastics that will probably never leave this earth. So the life cycle assessment for plastic is pretty terrible, which is why a lot of the times countries are now promoting the banning of single-use plastics. Okay, because that's exactly it. Their life cycle assessment is very low. So how is it carried out? We're going to be listing all the energy and material inputs and all the outputs into the environment. We're then going to be evaluating the potential environmental impact of these inputs and outputs, as well as interpreting the results to help make decisions about using the material, the process, the product, or the service over another. So something like using paper bags over plastic bags would be a better idea. The life cycle assessment for the paper bag will be a lot less because its impact on the environment is a lot lower than the plastic bags. This is what we're going to be using life cycle assessments to decide. Finally, when it comes to the use of these finite resources that are damaging to the environment, we just have to think of reduce, reuse, and recycle. A lot of the times, this will not only reduce the amount of plastic and the amount of waste that we produce by reusing it and therefore needing less, but it's also going to save us energy if we recycle these products. It's a lot easier to melt down your aluminium cans to make more aluminium products than it is to extract aluminium from the earth as well as refining it into new aluminium. You see, so as I mentioned here, there are social, economic and environmental issues associated with the exploiting of Earth's limited supplies of raw materials such as these metal ores. Okay, it affects every aspect of our life of how we use this. So next time you're in a shop, ask yourself, is this, let's say, sweet or packet of chips worth putting a plastic bag into the environment for the next couple hundreds of years for your single moment of tastiness? So be smart when you're buying products. Try and buy products that are recycled at the very minimum. Okay, try buy products that can be recycled, and try buy products that are going to be biodegradable. That will be your best bet at helping the environment while also supporting your own needs, is buying biodegradable products, so that the life assessment cycle, or the life cycle assessment, is going to be the very lowest. Okay, so my name's Cameron, and I will see you in the next lesson.